Hello everyone and welcome to Electrical Engineering, Electrical Motors. And today we are going to start off this electrical motor series by the basics part. So basics of electrical motors. What we will be seeing in this particular video is the basic working principle. So working principle of the electrical motors, some terminologies. So some terminology of electrical motors and basically what are the different types of electrical motors. And once we complete this video and in the further videos we will be looking like dissecting the different types, like how are motors classified and their particular construction and stuff like that. So let's start with our things. So first of all, what is an electrical motor? So when I say the term electrical motor, so let's say electrical motor, what does it mean? So basically the definition of an electrical motor is that it's a machine that converts electrical power or let's say electrical energy into mechanical energy. So this converts it into mechanical energy. So it's a device that converts electrical energy into mechanical energy. Now you might be asking what mechanical energy. So basically, say for example, you have an electrical energy which is your supply. So let's say supply, and this electrical supply is being converted to mechanical energy, which in this particular case of electrical motors is the rotation. So your supply, your electrical energy is being converted to the rotation, that is mechanical energy. And this is basically the definition of an electrical motor. So conversion of electrical energy into mechanical energy is the definition of a motor. Now, how does a motor work? Like, what is the working principle of a motor? So to understand the working principle, we need to understand two things. Okay. So before diving into the working principle, we need to understand two things. That is Lorentz force, and the other one is magnetic induction. Okay. So why we need to understand these two terms is because the definition, or let's say the working principle of a motor, is based on these two principles. So let's dive into the Lorentz force. So what does the Lorentz force say? It basically says that if a wire carrying electrical current is placed into a mechanical field, then it experiences the force. Okay. So to depict to you, so let's say this is a wire that is carrying an electrical current. If it's placed in a magnetic field, so let me depict the magnetic field by this yellow dotted lines. Okay, so if I place this wire, let's say W, in this magnetic field M, then this wire will experience force if it is carrying an electrical current. So my electrical current I is here. And here comes another thing in picture, or another, let's say, the rule in picture, that the direction of this force is given by Fleming's rule. So you have Fleming's rule, and this Fleming's rule will give you the direction of the force in which this wire carrying the electrical current will experience if it's placed in this magnetic field M. Okay, so this is the Lorentz force. And now let's get into what does magnetic induction tell us. So magnetic induction is basically if a current carrying coil has its own magnetic field. So let's say, to depict to you, this is a coil, right? So what is a coil? It's basically a looped wire, let's say. So when a looped wire is carrying a current I, okay, for example, this looped wire is carrying a current I, then it will have its own magnetic field. So in the Lorentz force, what it says that if a current carrying wire, okay, so this can be a coil, this can be a straight wire, this can be a small wire, a very long wire. So Lorentz force says that this wire, if placed in a magnetic field, will experience the force whose direction is given by Fleming's rule. But what does magnetic induction state is that if there is a coil and it is carrying a current, then this coil will have its own magnetic field. So these are the two, let's say, principles or theorems or rules on which the working principle of an electrical motor is based. So let me just clear this thing. Okay. So now that we have understood the Lorentz force, I will write it here. So Lorentz rule, my bad, not Lorentz force, Lorentz rule. And now that we have understood magnetic induction, we go to the working principle of an electrical motor. So the working principle of an electrical motor is when current is passed, when current is passed through a magnetic coil, magnetic field is generated. This magnetic field interacts with the static magnetic field, which in turn generates rotation. So yeah, it's a long definition or it's a long working principle. Let's break it down clearly. So what it states, when a current when a current is passed through a coil. So let's say this is my coil, okay? And when a current is passed through this coil, it will develop its own magnetic field. So to be better, let me say this magnetic field is developed like this around the coil, okay? And when this particular magnetic field comes in contact with another magnet, so we have another magnet. If these two come in contact, then a force is generated. So let's be clear. Okay, like let's be clear. How Lorentz rule is applied into this is a current carrying coil. Okay, when placed in a magnetic field or a current carrying wire is placed in a magnetic field, it will experience force. While as magnetic induction is where this current carrying coil has its own magnetic field. So basically, based on the interaction of these magnets or magnetic field, you will experience a force. And that's how you see generally in a motor. So you might have seen like you have the stator poles, the rotor poles. Sometimes, many times, the rotor is a magnet or like a permanent magnet, or the rotor is a wound magnet. The stator has coils around it like this. So whenever you pass a current through this coil, it generates its own magnetic field, which comes in contact with the magnetic field of the rotor, and you have the force. And then this force is what you see physically, like the motor is running. Okay. So this is the working principle of a motor. And then we will be dissecting it furthermore. Like this motor, we will be dissecting it in a furthermore. Okay. So let's come back to the basic terms that you have in an electrical motor. Like I was explaining to you the working, we heard the term stator. Okay. Then I mentioned the term rotor. So what is the stator? The stator in a motor is the static part. So a static part of this machine, let's say the motor. And the rotor, as the name suggests, is the rotating or the moving part. So moving slash rotating part. Okay. Then you have terms like air gap. What is air gap? Air gap is the distance between, like the air distance between the stator and the rotor. So it's the distance between stator and rotor. And then you have something as windings. So windings are basically the coils that are on the stator poles. So if you remember, like previously, while mentioning the working principle, I said like there is a stator. So this is my stator. And on the top of stator, you have these coils. And these wires, these, turned up coils are basically the windings of the motor. Okay. So these are the terms that you will be seeing frequently whenever a motor is mentioned. And based on the arrangement of these terms and, in detail, how and when the properties of these things are changed, we have different motors. And of course, not only these, but there are other properties. But these four terms are the very, important terms when you come to motor designing, or let's say in a generic field, electrical motors. And now that we have understood the working principle, the terms, the major terms that come in the motors, let's see, let's come to the type of electrical motors. So we have here, I'm sorry for it. So let's say we have the electrical motors, and we have a very broad classification of these motors. Okay. So we have the DC motors. Okay. We have the AC motors. And then we have special motors. So DC motors, direct current motors, AC current motors, and special motors, special motors. Okay. So like further coming down, what we have in these, let's say, as a sub classification, like what different types of motors are there and stuff like that. So let's dive into it, and then our basics will be covered. So we have the under the DC motors, the DC shunt motor. Okay. Then we have the sorry, all this. Then we have the separately excited DC motor. Then we have the series excited DC motors. Then we have the permanent magnet DC motors. And these are the motors that you might have heard very frequently, the PMDC motors. So yeah, these are the same permanent magnet DC motors. And the last one is you have the compound motors. Okay. So these are the types of DC motors. Then you have under the AC motors, you have the induction motors. So induction motors are very widely used in the industrial appliances basically are fans. The ceiling fans were also made of induction motors and are widely used in industrial appliances. And then we have the synchronous motors, which also comes under the AC motors. And then we come to special motors. Now what is special is like these might be excited by DC but work on an AC principle, might be, you know, excited by AC but work on a DC principle. So these are like special motors. And under the special motors, the very, let's say, widely thing is the stepper motors. So stepper motors, I will just write M because it saves space. Then you have the BLDC motors. So yes, again, BLDC motors you might have heard in a lot of applications. So BLDC stands for brushless DC motors. Why it doesn't come under the DC motors section is because the brushless DC motors have a separate excitation waveforms and separate excitation concepts. So yes, these motors are classified under special motors. Then you have something called as hysteresis motors. So hysteresis motors. Then you have reluctance motors. And then after all of these, under the special motors, you have universal motors. So on your screen, you can see like this is the broad classification of motors. And in the subsequent videos, we will be going deep into these separate motors one by one. And yeah, let me know how you felt about the video and let me know in the comments what you want to know more, or is there any specific topic that you want to know more, and I will try to include them in my next videos. Thank you.